Hi people, this is video tutorial 12, which is in the playlist devoted to the meshing of 3D experience meshing of the finite element model of a 3D experience platform, which incidentally is the Abacus program. In tutorial 11, I showed you how to view the top and the bottom surfaces of a shell element or positive and negative sides of the shell element. But I didn't do an example. So let me remind you what happened. And if you don't know this, I suggest that you watch video 11 first. But here we have a four-noded linear shell element. Okay, and the connectivity, when you say element E has node numbers 1, 2, 3, 4, or node number E, element number E has node numbers 4, 1, 2, 3, etc. That sequence, the way you say it, is actually give you, and the right hand rule will give you the direction of the normal to the shell or the positive side of the shell, and it's like that. So when you think about it, the positive side is obtained by taking this uh, element and lift it up by half the thickness and push it down by half the thickness, so you get the top surface or the positive side, which is called in magenta in 3D experience, and you get the negative side or the bottom side, which is colored in blue. We did that in tutorial 11. I showed you how to display it. I showed you how to flip the direction if you need it, etc. Now, here's the situation. Suppose I want to do a problem like this. I have a surface, I've meshed it, as you can see here, and uh, I want to put a pressure on it, and the left side is clamped. Notice that there's two things you have to do. You have to decide on this guy and the number that you put in here. So this means that the pressure that you're going to put on that surface is going to be put on the top side or the positive side of that shell element, wherever it happens to be. It could be up here or it could be below. It doesn't matter. All right, let's do another one. If you look at this, the arrow is, if you click on this arrow and it flips it, that means that that pressure is going to be placed on the blue side or the bottom side, same magnitude. Okay. Now, if you want to do this problem, for example, this kind of a thing, the alternative is to keep it on the top side but put a negative number here. And same thing down there. So what I'm saying is that the numbers that you put in here and these icons do matter. Okay. And that means it you should know where the positive and negative side of the shell elements are, or the top and the bottom side. Now, by looking at it, you cannot predict which way the plate bends unless you know where is the positive side and where is the negative side. So that is also important. Very frequently, we don't pay attention to these things. We run it. If it doesn't look, it doesn't bulge out the way it's supposed to, or bulge in the way it's supposed to, we're going to change the number. But we don't usually pay attention on, uh, what exactly is going on. Now, let me remind you that when we're talking about positive, a positive value of pressure is pushing into something, and a negative value of pressure is pulling away something. So that just keep that in mind because that helps you to understand some of the things that's going on. So let's look at this problem. So it's the same one that we looked at before, but the positive side you can see it's over here, right there. So if you keep the arrow like that, that means you're applying a pressure on this side and a positive value of the pressure. That means you're actually pushing into this, which means it's going to go down right there. Let's try another one. If you keep the top just like it is, okay, top side, and put a negative value of the pressure is, means you're pulling away. That's why it bends up. So this way you can justify these all possibilities. If you look at this situation, for example, let me go back here for a second, right there. If you take the bottom side is what you cannot see here. You put a pressure, positive value of pressure. That means you're pushing into the blue. That means this is going to go up. Oops, this is going to go up, etc. This is how you can now notice that here, for example. Let's go back. Suppose we flip these and you, the arrow looked like this. The top side, positive. The top side is actually, you cannot see it. It's down below. Magenta is below. And a positive number. So you're pushing into magenta. So this is going to go up, etc., etc. So I'll do a couple of these and then leave the rest of them to you. So these are basically exactly what I said, except that it's written on the slide. I'm not going to dwell on it because we already discussed this. And I also mentioned in tutorial 11 is that in some software, Abacus, you can actually show, for example, Abacus, you can actually show the coordinate system for the triad coordinate system for the shell. And you can do it here too, except that only after you run the result. Here, it's only magenta and blue that can be shown at the meshing stage. But if you run it with some boundary conditions, etc., then you can come back and do post-processing and say, show me the orientation. I could not figure out how this can be done before you actually run the problem. Okay, maybe there is a way of doing it, but I don't know how. Okay, so let's go ahead and do this problem. We start with a generative shape design. Okay, so on this vertical plane, I will sketch just a line 40 millimeters long. Okay, that is the width of the plane exit, and sweep extruded by 120 millimeters. Okay, good. Why don't we apply material properties to this? Let me create a material. I'm going to call it steel, January 6, 2024. Say okay. And now once the template is created here, I'm going to apply it. On this part. And all we need to do is to put the Young's modulus and Poisson ratio. So structures, Abacus multiphysics, mechanical, elasticity, elastic, 200 gigapascal, Poisson ratio 0.3. All right, let's move on. Now we're going to go to structural model creation to mesh this thing, MTFEM. Select that, we are in the meshing tab right there. You can see that. So let's do a surface quad mesh. On the surface, 40 millimeters, mesh it. You're going to get three elements, linear elements like that. And now, remember, you can look at you can view the top and the bottom surfaces of this of these elements. So what you need to do is to go to display right there. See that? Display. And over here, you this right now the top and the bottom surfaces are not shown. But if you go here, then it says kind of normalish icon. So if you click on it, it shows you that the top is uh, negative. This view thing that you see, you're seeing is the negative side of the shell, and the here thing that you cannot see is the positive side. Now, incidentally, if you hide the extrude, it's easier to see what's going on right there. So one side is negative side, the other side is the positive side. Okay, let's move on. Now let's apply material properties to these properties. Well, material properties is already defined, so we're going to do shell section on this surface, on this extrude surface, and let's put a 10 millimeter or 5 millimeter 5 millimeter thickness, and we say okay. Good. As far as the model is concerned, we are done. So we're going to go to the structural scenario creation, and we use this finite element model that was created. All right. And we're going to create a static step, not take away the nonlinearity. So I expanded advanced and unchecked the include geometric nonlinearity. Incidentally, if that's what I wanted to do, I could have used the uh, static perturbation. That will effectively do the same thing, but that's how I approached it. Now, we're going to clamp the left side. So we go to boundary conditions, boundary condition, and let's find the clamp, or instead of clamping, I use fixed displacements and rotations. Fixed displacement and rotation. The only reason I don't like clamp is that the icon associated with it, it's something that looks like a yellow ball. You can hardly see what's going on. So I'm going to click on the fixed displacement on this edge. Now, the reason I can't pick the edge is because I hid the surface. That's why I have to get it back. And now I can select this edge. Should be. Zoom in. Oh, select hide the sketch. I forgot hide the sketch. So you get the surface to show, but the sketch to hide, because you cannot put a boundary condition on the sketch. And check all the degrees of freedom. So this is essentially a clamped end. Okay. So now we're going to apply pressure on the top. So under loads, let's find the pressure somewhere here. Now notice that support, I'm going to select the extrude. Okay, no problem. Because this arrow is pointing up, that means that this pressure is going to be put on the top surface of the shell, which means at the bottom, right? Remember, the top surface of this magenta was at the bottom, okay? And if you put a zero point 0.1 megapascal here, so essentially this is going to push this thing up, all right? It's going to push it up. And we're going to run, should push it up. I'm not going to do the model check and the simulation check. It's a very simple problem. I know it's going to work. This is going to get pushed up. Okay, it finished running. This is going to get pushed up. All right, so close this, pushed up. Now, let me go back here. Let me go back to scenario. Suppose I go to my pressure loading right there and click on this arrow, push it, click on this arrow. That means that the pressure is going to be placed on the negative side or on the blue side. And since the value is also a positive number, that's going to push this thing down. Check it out. The whole idea of this tutorial 12 is to take the trial and error and guessing out of the picture. Okay, so tutorials 11 and 12 basically give you a systematic way of predicting these things. Okay, so this is going to go down, guaranteed. Good. Now let's go back to scenario and go back to the pressure. Keep it still at the bottom, but put a minus sign here. That means that the pressure is placed on the negative side, blue side, because of this arrow pointing down, bottom side, but there's a negative. That means actually it's pulling away. So this is going to go up now. And after I convince you that this is the case, I'm going to go and flip the direction of magenta and blue so that the direction of the normal to the shell is reversed, and we try to few cases like that. This is how I have got these plots for you. Okay, right now we are dealing with a situation where blue was on the top, right there. See that? I'm doing these cases. Then I'm going to flip the direction of the normals and do a few cases, or maybe one case. Okay, as I expected. Now, let's go back to let's go back and flip the direction. How do we flip the direction? We have to go to the measure. Go there. Okay. There is a this. There is a over here when you're in the measure. There is the meshing editor. This is how you flip the direction. You click on it. You say OK, and let me see for a second. Yeah, you select that surface. The menu changes. You select the surface, the menu changes, and this is where you flip directions, flip elements. Notice that when I do this, and I say flip all, doesn't matter which one I pick, it's going to flip them all. The top is going to become magenta. Now, I can close this. One thing you should not forget is exit. Because if you don't exit, it doesn't recognize that there was a switch here. And when you try to run it later on, you're not, it's not going to give you a warning. But when you try to run it later on, it says this surface cannot be found, this pressure cannot be found because you did not exit properly. In fact, in fact, yeah, I'm not going to do that. Exit. Now we go back to our scenario. Here's the situation. Let's first of all see where's the top. The top is magenta, right? So let's look at the pressure, see what happened here. The pressure that we apply, the pressure that we currently have is at the bottom surface. Bottom surface means down below because magenta was on the top. Okay, magenta was on the top. So this pressure is at the bottom surface and it's negative. So it's not going to push into the blue, but it's going to pull it away. This is also going to bend down. This is going to go down. Go down, down. Okay. And finally, if you go back here, if you go back here and go to the pressure and flip take this minus away, notice that the pressure is applied at the bottom side. We took the minus away. Bottom side, the blue is at the bottom. A positive number means it's pushing into the blue. So this is going to go up now. It should go up. Okay. Blue is at the bottom. Don't let these things fool you. Blue is at the bottom. It's applied to the bottom with a positive number. So it's going to push into the blue. So that means it's going to go up. So you can see that that figure actually does not show that, but this is going to go up. Okay, go up there. Now, before I show you that if you don't exit that mesh modifying, flipping the normal, you're going to get an error message. Before I do that, let me show you something. If you go to the plots and if you click on, if you go to the plots and find the plot which says symbol plot, you can select the orientation, and then say apply. So it will also show you the normal to the shell. Now remember, this is the problem where magenta was on the top, therefore the normal should point up, and you can see that it is pointing up. Now this, I could not figure it out to how to do it before you run, but anyway, it's there.